Hello students, welcome to my channel Engineers Academy. Kindly subscribe my channel. Now I am going to solve this particular problem. Again, in this problem it is said that determine the force in each member of this truss, and it is said that state if the members are in tension or compression, right? So this problem is a bit long, right, since we have a total of 15 members in this given truss, right? So we need to find the forces in all the members, right? So 15 members of this truss, right? So first of all, what we will do is that we will start with the supports, right? So I will find the reaction forces at A. So let's say that at point A we have, since here we have the roller support, so we will have this force which will be acting upward, right? So let's say that this is AY, right? And let's say that the reaction at E, since it's a pin joint, so here we will have two reactions, right? So here we will have EY reaction and here we will have EX reaction, right? So to find these three support forces, these three reactions, first what I will do is that I will apply the summation of the moments about point E equals to 0, and we will assume that the counterclockwise moment is positive, right? So now as we can see that this 3 kips force and this 3 kip force is producing the counterclockwise moment about this point E. So I will write plus 3, and the perpendicular distance of this force from that point E is this 10 feet. So I will multiply this with 10. Similarly, this is also producing the counterclockwise moment. So we will write plus 3 into 10 plus 10. So this is 20, right? And similarly, this 2 kip force is producing the clockwise moment about that point E. So I will write minus 2, and the perpendicular distance of this 2 kip force from that point E is 12, right? So 8 plus 4, it is 12. So I will multiply this with 12. Similarly, this is also producing clockwise moment. So I will write minus 1.5, and the perpendicular distance is this 4 feet. So I will multiply this with 4. And similarly, this AY is producing the clockwise moment about that point E. So I will write minus AY, and the perpendicular distance of this AY from that point E is 40 feet, right? So 10 plus 10 plus 10, so this is 40 feet. So I will multiply this with 40, and this will be equal to 0. And if we bring this to the other side of equation, so this will become positive, right? So we will be left with this. So we can find it directly by using calculator. So this will give us AY, which is 1.5 kip, right? So I will write this here, the result here, right? So this is AY is 1.5 kip, right? And we can directly write that this here, this force is 1.5 kips, right? And similarly, if you want to find this EX and EY, so if I apply the summation of forces along X equal to 0 to this whole truss, right? So then we can see that this EX is acting in the negative X direction. Or first let me write that this 2 kip is acting in the positive direction, so I will write plus 2. This is also acting in the positive X direction, right? This is plus 1.5. This is our coordinate system, right? This is plus X and this is plus Y, right? And similarly, this EX is acting in the negative X direction, so I will write minus EX. This is equal to 0, and from this we can say that EX is equal to the summation of this, and from this we can write that EX is 3.5 kip, right? Similarly, if we apply the summation of forces along Y equals to 0, so as we can see that EY is acting in the positive Y direction, so I will write EY. This is acting in the negative, so I will write minus 3. This is acting in the negative direction as well, so this is minus 3, and this is acting in the positive direction, so it is plus 1.5, right? So this is plus 1.5, and this is equal to 0. From these signs will become opposite if we bring these to the other side of equation, right? So this will become 6 minus 1.5, so this is 4.5. So EY is 4.5 kips. So now we can write that EX is 3.5. Let me write here that this is 3.5 kip, and EY is 4.5 kips. So before going to start the solution of each joint to find the force in each member, first we need to find this particular angle, right? We need to find this angle. If I draw a horizontal line here, so we need to find this theta angle, right? So let's say that this angle is theta. So if this is theta, then this angle is also theta, right? Since this height of, if we consider this HIG triangle, so then the base of this triangle is 8 feet, right? And the height of this triangle is 10 feet, right? So this triangle is symmetrical about this horizontal line. So if this is theta, then this is theta, right? And similarly, if this is theta, then this is also theta, and this is also theta. So all of these triangles are similar triangles, right? And similarly, if we look into this small triangle, this ABI triangle, right? So this height is 4 feet and this is 10 feet, right? So if this is 10 feet and this is 4 feet, so if this is theta, then this is also theta, right? So all these angles are thetas, right? This is theta, this is theta, right? So we have to find this only one theta, and all these angles are thetas, right? So we can apply tan theta to this triangle, this HG, and let's say here is we have x, right? So HXG triangle. So if we can apply tan theta, so tan theta will be equal to this perpendicular. We have this triangle. Let me draw it here, right? So we have this triangle. So this height is 4 feet, right? We are considering the half of this. So this is 4 feet and this is 10 feet, right? So tan theta will be 4 divided by 10, and theta will be equal to tan inverse 4 divided by 10. So this comes out to be 21.80, right? So let me write that theta here, right? This theta is 21.80 degrees, right? So now we will start from this joint A. Since at joint A we have one known force and two unknown force, right? So we usually start the solution with that particular joint where we have at least two unknown forces and one known force, right? So at joint A we have one known force and two unknown forces, right? So now we will consider joint A for equilibrium, right? So let's assume that at joint A, member AB is applying the force in this direction, right? And similarly, member AI is applying the force in this direction, right? So if I draw this free body diagram here, right? So I will represent these forces by their names, right? So instead of writing FAI force, I will only write AI, right? So this will represent AI member force, right? This will make our life easier, right? So we will not need to write this F with each and every force, right? So this is AI member force and this is AB member force, right? And we will use this cos of theta and sin of theta values again and again. So I have calculated these values and I have written these values, right? So whenever we will use cos theta, so instead of cos theta I will write minus 0.928, and instead of sin theta I will write 0.371, right? So now as we know that here we have that same theta, right? So here we have that same theta as well here, right? So this is the free body diagram for joint A. So now to find this AB and AI member force, we need to resolve this AI member force into its components, right? So it will have two components. It will have one component which will be acting downwards, and it will have one component which will be acting in this direction, right? And this is that AY force, this is 1.5 kips, right? So if I apply the summation of forces along y equals to 0 at joint A, so as we can see that this component is acting in the negative y direction and it is the sine component of AI. So sine value is 0.371, so I will write 0.371 AI, and this is acting in the positive y direction, so I will write minus 1.5, and this is equal to 0, right? So from this AI equals to 4.04 kips, right? And since AI is acting towards this joint A, so this means that this is compressive force, right? Similarly, if we apply the summation of forces along x equals to 0, so as we can see that this AB is acting in the positive x direction, so I will write AB, and this component is acting in the negative x direction, and it is the cos component of AI, and cos value is 0.928, so I will write 0.928 AI, and AI value is now known, right? So this is into 4.04, and this will be equal to 0, or we can say that AB is equal to this thing, right? So AB is 3.75, right? So I will write that AB value is 3.75 kip, and since AB is acting away from this joint A, so this means that this is the tension force, right? Now after this we will consider joint E for equilibrium, right? So I will write joint, since at joint E we have two known forces and two unknown forces. So now let's say that we draw the free body diagram. So at joint E we have this 3.5 kip force, right, which is acting in the negative x direction. So I will write this is 3.5, and we have this 4.5 kip force which is acting in this direction, and let's assume that this EF member force is acting away from this joint E, right? We are assuming both the direction as tension forces, right? And similarly, let's assume that this DE member force is also acting away from this joint E, right? So this is the DE member force, and this is that joint E under consideration, right? So this is EF and this is DE. So again we have that same theta here, right? So again we need to resolve this EF into its components. So it will have two components. It will have one component like this, and it will have one component which will be acting vertically upward, right? So now again if I apply the summation of forces along y equals to 0, so as we can see that this sine component of EF is acting in the positive y direction. So this is 0.371, sine value is 0.371, 0.371 EF plus 4.5, and this is equal to 0. So from this EF will be negative, right? So we can write that EF is, so this is 12.13, right? So I will write that EF is minus 12.13, and since EF is acting away from this joint E, but the sign is negative, so this means that this is acting in the opposite direction. So this means that EF force is compressive force, right? So this EF force is compressive force, right? Now if I apply the summation of forces along x equals to 0, so now as we can see that this DE is acting in the negative x direction, so I will write minus DE. This component, this cos component of EF is acting in the negative x direction, so I will write minus, cos value is 0.928 EF, and EF value is now known, which is minus 12.13. This 3.5 kip is also acting in the negative x direction, so I will write minus 3.5, and this is equal to 0, right? So from this, if we bring this DE to the other side of equation, so this will become positive. So DE will be equal to the summation of both of these, right? So I will write this is plus 7.76, right? So DE is 7.76 kips, right? And since DE is acting away from this joint E, so this means that this is the tension force. Now after this, if we consider joint B, right? So joint B, if we consider the free body diagram of the forces at joint B, so we will have the AB force. AB force is tension force, so we will have AB force which will be acting in this direction, and similarly if we assume that BC force is acting in this direction, and let's say that BI force is acting in this direction, that is vertically upward, right? So at joint B, if we apply the summation of forces along y, so this BI member force will be equal to 0, since there is no other force along its direction, along its line of action of force, right? So this means that BI member is a 0 member. If we apply the summation of forces along y equals to 0, so BI member will have 0 force, right? And similarly, if this is that BC force and this is that AB force, so this means that if we apply the summation of forces along x equals to 0 at joint B, so this BC is acting in the positive x direction and this AB is acting in the negative x direction. So from this we can write that BC is equal to AB, right? So AB force is known, which is 3.75. So I will write 3.75 kips, and is we have assumed that BC is acting away from this joint B, so this means that this is the tension force, right? So from this we can conclude that whenever we have such a situation that we have three forces and there is no external force at that particular joint, so if two of these forces are collinear with each other, so the third force will be the zero member force, or the third force will be zero, right? The similar case is at this joint D, right? So if we consider joint D for equilibrium, so again at this joint D, if we draw the free body diagram, so we know this DE member force, so DE member force is again, this is a tension force, so again it will be tension force here as well, right? And similarly, let's assume that this is that CD member force, this is that CD, and this is DE, and let's assume that this is DF member force. So again, DE and CD forces, they are collinear with each other, and along the line of action of this DF there is no other force, so this means that this DF force is again 0, right? So this means that if we apply the summation of forces along y equals to 0, so DF will be equal to 0. So again we can write directly that DF is a 0 member, right? And similarly, if we apply the summation of forces along y equals to 0, so DE is acting in the positive x direction and CD is acting in the negative x direction, so this will be equal to 0. So this means that CD is equal to DE, so we can write that CD is equal to DE, and DE is equal to 7.76. So I will write that this is 7.76 kip, and since CD is acting away from this joint D, so this means that this is the tension force as well. Now after this I will go for joint H, right? So joint, since at joint H we have one known force and two unknown force, right? So this will be easier to solve, right, relatively. So again, let's say that at joint H we have this GH force in this direction, and let's say that the HI force is acting in the downward direction, let's see. So now if we consider this as a free body diagram, right, so here we have that 2 kip force as well, right? Let me put it here. So we have that 2 kip force acting in this direction as well, right? This is the external force, right? So this is 2, this is that joint H, this is GH force, and this one is HI member force, right? And again, if this is that theta, so then here we have that same theta as well, right? So if we resolve this GH member in force into its components, right, so we will have one component in this direction, right, and this one will be the cos component, right, and here we will have one component which will be acting in this direction, right? So again, if we apply the summation of forces along y equals to 0, right, so as we can see that this component is acting in the positive direction, and if this is their theta, so this is the sine component, and sine value is 0.371, so I will write 0.371 HI minus, sorry, this is 0.371 GH, this is the component of GH, right, so I will write that this is 0.371 GH minus this HI, so this is equal to 0, right? And since both of these are unknown, so again we will apply the summation of forces along x equals to 0. So now as we can see that this 2 kip force is acting in the positive direction, so I will write 2, and this component, this cos component, is acting in the negative x direction, so this is GH cos of theta is 0.928, so I will write minus 0.928 GH, and this is equal to 0. So from this, GH is equal to 2 divided by 0.928. So GH is 2.16. So I will write that GH is 2.16 kip. And as GH is acting towards this joint H, so this means that this GH is the compressive force, right? This is compressive force. So now since we know GH, so we can find HI from this equation. So if we bring this to the other side of equation, so this will become positive. So this means that this is equal to 0.371 into GH, which is 2.16. So HI is equal to 0.80. So I will write that HI equals to 0.80 kip, and since HI is acting away from this joint H, so this means that this is the tension force. Next we will consider joint I for equilibrium, right? So let me write that joint I, right? So this is joint I, so let me draw the free body diagram for this joint I. So here we have that 1.5 kip external force which is acting in the positive x direction. This is 1.5 kip, and similarly this AI force is known. So AI force is compressive force, so it will compress this this I joint as well. So I will draw this as AI force. This is that AI force, and its magnitude is now known, which is 4.04 kips, right? And similarly this BI member force is 0, so there is no need to draw the force for this member. And this HI member force is known, which is tension, right? So it will be acting away from this joint I, right? Since its magnitude and direction is known, right? It's 0.80, so I will write that this is 0.80. And similarly we will assume that this GI member force is tension force, so we will assume that it is acting away from this joint I, right? Let me write that this is GI member force, and again we will assume that this CI member force is acting away. This is tension force, right? We will assume that this is, let's say that CI member force, right? So now if I draw a horizontal line here, so this GI member force will be making that same theta, and this CI member force will be making that same theta here, right? So this is that same theta and this is that same theta. So to apply the equilibrium condition, first we have to resolve these forces, right? So this GI force will have two components. It will have one component like this, and it will have one component like this. And similarly this CI force will have one component like this, and it will have one component like this, right? And similarly this 4.04 kip will have one component in this direction, and it will have one component which will be acting in this direction, right? So now if I apply the summation of forces along x equals to 0 at joint I, so we will have this component, right? So this is the cos component of GI, right? So the cos value is 0.928, so GI cos of theta is 0.928 GI. And similarly this component of CI is also acting in the positive x direction, and it is the cos component, right? If this is that same theta, then this is also that same theta. So this is the cos component, so I will write that this is plus 0.928 CI. And similarly this component, this cos component of this 4.04 is also acting in the positive x direction, so this is again plus 0.928 4.04, and this 1.5 external force is also acting in the positive x direction, so I will write plus 1.5. This is equal to 0. So now if we divide this whole equation by 0.928, so we will be left with GI plus CI plus 4.04 plus 1.5 divided by 0.928. This will be equal to 0. And if we add both of these, so we will be left with 5.656, or we can say that GI plus CI is equal to minus 5.656, right? Similarly, if we apply the summation of forces along y equals to 0, so again we have this component. This is acting in the positive y direction, and it is the sine component, and sine of theta is 0.371, so we will write that this is 0.371 GI. Similarly this component is also acting in the y direction. This is in the negative y, so I will write minus, and this is the sine component again, so this is 0.371 CI. And similarly this is also acting in the positive y direction, and again it is the sine component, so I will write plus 4.04 0.371, and this 0.80 is acting in the positive y direction, so I will write plus 0.8, and this is equal to 0. So again, if we divide this whole equation by 0.371, so we will be left with gi. Let me write this equation here, right? So this is gi, this will be minus ci, so this will be 404 plus 0.8 divided by 0.371, and this will be equal to 0. And if we simplify this, so this is equal to 6.196, so this is 6.196, and this is equal to 0. And if we bring this to the other side of equation, so this will become minus. So we will be left with these two equations. So we have two equations and two unknown, right? So now if I add these two equations, so if we add both of these equations, so then this will cancel out. We will be left with 2gi, and this will be equal to minus 11.852. And if we divide this by 2, so then gi equals to minus 5.926, right? So since we have minus sign, so this means that the assumed direction of gi is not accurate. It is acting towards this joint I. So this means that gi magnitude is 5.926 kip, and it is the compressive force. And similarly, if we put this gi value in one of these equations, so then we will get that ci value. So then ci will be equal to 0.27. So this is 0.27, and we get positive sign. So this means that the assumed direction of ci is accurate. It is the tension force, right? So this is the tension force. Next, we are going to consider this joint F for equilibrium, right? So let me draw the forces at this joint F. So as we know that this DF member force is 0, and we know the magnitude of this EF force. So EF force is, here we have that EF force, it's a compressive force, so it will have direction like this. It will also compress this joint F as well, right? So we will have this EF force, and similarly we will assume the GF member force. So let's say that this is the tension force. We will always assume the tension forces, right? And let's say that the CF member force applies the force in this direction at this joint E, right? And this DF member force is 0, remember. And similarly we have this 3 kip force which is acting vertically downward, right? So now let me isolate this free body diagram here. So this is that 3 kip force. Let me write that this is the 3 kip force, and this is EF member force, and EF member force magnitude is known, which is 12.13. So I will write that this is 12.13, and similarly this is not known, this is CF member force, and this is not known, this is FG, right? So again, if we resolve these forces along this positive x and y direction, so we will have two simultaneous equations, right? So to avoid solving that simultaneous equation, now what I will do is that I will consider the axis is at another orientation, right? So let's say that this is my positive x direction now, right? So let's say that this is our positive x, and we are assuming that our x-axis is along this FG members, this FG member and this EF member, right? This is that EF member force, and this is that FG, right? So we are assuming that now the axis is along these two forces, right? So this will enable us to eliminate one member force, right? And similarly, let's say that this is our y-axis is perpendicular to this x-axis, right? Perpendicular to these two forces, this GF member or this FG member force, and this 12.13, this EF member force. So this is our plus y direction, right? So now as we know that this CF member force is making here angle theta, right? So this angle is theta, and similarly this FG or GF member force is making angle theta here as well, right? So this means that this CF member force is making 2 theta angle with the positive x-axis or with the x-axis, right? And similarly this y-axis is perpendicular with this line, and this 3 kip force is perpendicular with this horizontal line, right? So the angle between horizontal and this line is theta. So this means that this 3 kip force is also making angle theta with the y-axis, right? This is our 3 kip force, right? So now if we resolve these forces into its components, right? So we will have this CF force will have one component should be acting in this direction like this, and it will have one component should be acting in this direction, right? And similarly this 3 kip force will have one component should be acting in this direction, and it will have one component should be acting in this direction, right? But as we know that if this CF force is making 2 theta angle, right? Remember, so let me write that this is 2 theta angle now. So this angle is 2 theta, right? So now this will be the cos component and this one will be the sine component, right? So now if I apply the summation, let me write that joint F, this is joint F, right? And if first let me write that the summation of forces along y equals to 0, right? So as we can see that this is now our y-axis, right? So now as we can see that this component of this 3 kip force is acting in the negative y direction, and this is the cos component, right? So we will write that this is 3 cos of theta, and cos of theta is 0.928, so I will write 0.928, and this CF member force will have one component which is acting in the negative y direction, and this is again the sine component, right? According to this 2 theta, this is the cos component and this is the sine component. This is the 2 theta angle here, right? So this is the cos component and this is the sine component. So we will write that this is minus CF and this is sine 2 theta, right? So 2 theta is 21.80, right? So we will write that this is 2 times 21.80, so this is equal to 0. So now we can solve this. We can write that if we bring this to the other side of equation, so this will become positive. So from this we can write that CF is equal to, so this is equal to 4.04, right? So CF is, this is 4.04 kips, and this is also negative, right? We have done one small mistake. This is minus, this component is also acting in the negative direction, right? So this is minus, right? So if this is minus, so then the CF is also minus, remember, right? So this means that the assumed direction of CF is not accurate. So this means that CF is compressive force and its magnitude is 4.04 kips. This is compressive force, right? Now if we apply the summation of forces along x equals to 0, so then as we can see that this GF force is acting in the negative x direction, so I will write minus GF. This component is acting in the positive x direction and it is the sine component, and sine value is 0.371, so I will write that this is a plus 0.371 into 3. Similarly, this component is also acting in the negative x direction, so I will write minus, and this is the cos component of CF, right? And CF magnitude is minus 4.04. According to our assumption, this magnitude is minus, so we will use this minus value. So this is minus 4.04, and this is cos of 2 theta. So cos of 2 theta, and theta is 21.80. And similarly, this 12.13 is also acting in the negative x direction, so I will write minus 12.13, and this is equal to 0. So now we have only one GF as an unknown, right? So we can, if we bring this GF to the other side of equation, so this will become positive, right? So this will be GF. So GF is equal to this thing, right? So when we solve this, so GF member force is equal to, this is 8.08, right? We got this is minus 8.08, so this is minus 0.808 kips. So this means that GF is also compressive force, right? So this means that this GF is also acting towards this joint F, right? So we can write the GF magnitude is 8.08 kip, and this is also compressive force. Now we are only left with this GC member force. So you people can solve it yourself, right? So you people will consider this joint C and you people will apply the summation of forces along Y. So then you people will be able to find this GC member force. So I hope you people would have understood this very lengthy problem. So kindly like my videos if you want me to solve such more problems.